This is everything you need to know about the systems architecture topic of GCSE OCR Computer Science. For this part of the exam, OCR expects you to know a few things. What happens during the fetch execute cycle and each component's role in it. You also need to know what each register stores and the difference between data and addresses. However, you don't need to know how data is passed between registers during each stage. The CPU fetches and executes instructions stored in main memory or RAM. The way this works is that data is fetched first, then interpreted by the control unit. Finally, the instruction is executed, calculations performed, and this process repeats. Two parts of the CPU are the control unit and arithmetic logic unit. The control unit sends signals to direct CPU operations, control and timing signals, and decodes instructions. The arithmetic logic unit performs arithmetic, logical, and Boolean operations. Cache is also very important. It is high-speed memory storing recently and frequently used instructions. It is volatile and located either in or close to the CPU. When the CPU fetches data, it first checks cache before going to RAM. The CPU contains registers too. They are small pieces of memory that store one instruction. They are the program counter, which stores the address of the next instruction to be run and increments during each fetch execute cycle. The memory address register, storing the address of the data or instruction being processed. The memory data register, storing the fetched data, and the accumulator, which stores the result of arithmetic calculations. For this part of the exam, OCR expects you to understand each of the characteristics that will be covered shortly and know the effects of changing any of these characteristics on performance, both individually and in combination. Clock speed, measured in gigahertz, is the number of cycles per second. A faster clock speed means more cycles per second, so more instructions executed per second, and therefore more tasks completed per second, making software more responsive. Cache can be multi-layered. The closer the layer, the smaller and faster it is. Multiple levels of cache is necessary, as if it gets too big, it can negatively affect performance. Cache increases CPU performance, as it responds 100 times faster than RAM. A multi-core processor contains more than one CPU, each having its own components. This allows parallel processing, meaning each processor can execute separate instructions simultaneously, further allowing for multitasking as cores process instructions independently. Common names for these are single for 1, dual for 2, quad for 4, penta for 5, hexa for 6, octa or octo for 8, and deca for 10. For this part of the exam, OCR expects you to know a few things. What an embedded system is and their typical characteristics. You also need to be familiar with a range of different embedded systems. An embedded system is a computer system that is built into another device. Embedded systems have many characteristics, including limited functions, being part of another larger machine, therefore fitting into another device, having a single circuit board with its own processor, memory, and input-output interfaces, as well as using little power, being able to run on small power sources. General purpose systems are different to embedded systems. They are quite like the opposite of them. General purpose systems can perform multiple functions, have multiple chips, and are self-contained. Examples of general purpose systems are laptops, desktop PCs, tablets, and smartphones. Examples of embedded systems, however, are washing machines, digital cameras, microwaves, dishwashers, ATMs, calculators, automated car lights, sat nav, automated car parking, and airbag control.